All right, guys, we'll go ahead and get started. Good morning. My name is Ashwath Murthy. I'm the product manager for user ID and authentication. We have a few other presenters with us here. We have Siva, who's going to be talking to you about GlobalProtect internal mechanics. We also have Andy Fischbach here, who will be talking to you about how you might be rolling this out and how you might set something up with GlobalProtect. The goal for this session is to give you a little bit of a view into what happens behind the scenes with GlobalProtect as you use the client, as it talks to gateways, as it talks to portals, and crucially, as GlobalProtect authenticates users to bring in the remote security angle from a security posture standpoint. Now, before we go deep dive under the hood for this session, a couple things. We'll be talking about two separate angles here. We'll be talking about GlobalProtect itself as it stands, as a client, as it interacts with the Palo Alto Networks gateways. We'll also be talking about how GlobalProtect relates to user ID and security. And finally, Andy will be covering a few examples on configuration and use cases. A few things that are good to know. They aren't really prereqs as much as it's a good to know. It'd be good to know what a gateway happens to be, what a portal happens to be, where the GlobalProtect client might live. And critically around things like host information profile, just a concept or just a notion of what a host information profile happens to be, how you'd leverage it in policy. If you had heard of these terms before, if you've used these before, it'll be easier to follow along as we go through the session. Yep. If not, just get us to slow down. We can do that, and we can get in more color as we go through these slides. Before we kick it off, we'd like to talk about authentication and user ID with GlobalProtect. And the reason for this is GlobalProtect is central to the notion of reliable, secure user ID and strong authentication for all of your users who are on the network. Typically, you'd have seen that when setting up GlobalProtect, you have to attach an authentication profile. The authentication profile could be LDAP-based, radius-based. In the recent past, we've added TACACS Plus. Not that we'd expect anyone to use it, but it's there. Till now, you had an option to use Kerberos as an authentication profile. Critically, though, it was not Kerberos from the standpoint of true Kerberos single sign-on. It was Kerberos pre-authentication, so the user would key in their username and password, would mount a Kerberos pre-auth. KDC would come back and say, hey, this is good. Do you want to continue this transaction? And we'd say, no, we just want to stop, and we'd exit. In PANOS 7.1, we now have the ability to use Kerberos for true transparent single sign-on for GlobalProtect when it's being used in internal mode on Windows devices. To break down this transaction, which is the last one, what would actually happen in this case is very different from what you might be experiencing with GlobalProtect today. We'd expect the client to have authenticated, and we'd expect the client to have already have a ticket granting ticket. So you've already talked to the KDC, you've gone through pre-auth, you have a TGT, and now what happens? The client will make a request to the portal or to the gateway and say, hey, I want to connect. And the portal or the gateway is going to come back and challenge this client to authenticate. Now, this is coming back as a 401 HTTP, and it comes back with the authenticate header, and it says you must negotiate this, and we're not expecting a username and password in this case. The client looks at that response and now knows that it's in a single sign-on Kerberos transaction, reaches out to the KDC with the TGT and says, hey, here's a TGS request. This is the service that just asked me to negotiate and authenticate for a transaction. Can you please hand me a service ticket? The KDC, if you have the privileges to do this, you have the rights to get the service ticket, comes back to you with the service ticket. The client then bundles that into a Spinego token, kicks it back out to the portal or to the gateway. The portal and the gateway will then unbundle this Spinego token, decrypt it, look for the identity of this user, make sure that it's the correct service that is being accessed, and if everything works out, it's going to go ahead and provide you with access. Now, nowhere in this transaction do you have usernames and passwords. All of that is done behind the scenes, and it's true Kerberos single sign-on now, as long as you're in internal mode and you're using a Windows device. Critically, though, something that you need to think about if you're deploying this is that in this state here, you need to allow communication from the client out to the KDC, which means that your rule base potentially needs to allow what might be an unknown user to use the Kerberos app ID to talk to KDC. If you don't have that set up, this transaction will happen. If this transaction will happen, we can get a ticket. If we can't get a ticket, we can't authenticate. So this has implications for your security rule base as well. We'd expect there to be a rule in there that says unknown users, source zone is user zone, destination is the KDC, app ID equals Kerberos, and the action is permit. Without that rule, this is not going to function. Yeah? So just keep that in mind. This is really cool because it removes the need for usernames and passwords to be stored within the application. Single sign-on, so transparent for the user. You don't have to worry about password changes, so on and so forth, and the user having to change their password in 4 different places. It's all taken care of simply because we're using the Kerberos protocol. This is key. Single sign-on is great, but if you have someone's username and password that's already been stolen, who can hit Control-Alt-Del and log on to my Windows workstation, it's not going to help because the credentials are already gone. We would strongly, strongly urge you to deploy two-factor or multi-factor authentication on every single external gateway that you have with GlobalProtect. And the reason for that is credential theft. You don't want someone's credentials to be phished out of band, say when they're on vacation, they're traveling, they get a spear phishing email, they click on it, give me my username and password. Does this now mean that this bad actor have access to my entire network and they can just connect in, VPN in, game over? You don't want that, and we would require MFA for external gateways. So force two-factor when you're in external gateway mode. And this is typically achieved using Radius. It could be a hard token, such as RSA, Entrust, et cetera. It could be a newfangled application like the ones from Ping or Okta or any of these guys, where you just press the green button and you're good to go. All of it is plumbed through Radius. There is really no custom hook anywhere. And the interface is the same across all of these vendors. Plug us into the Radius box, have that mount a challenge for a one-time password. GlobalProtect goes to the prompt if it's a token. If it's an out-of-band ecosystem, such as a phone swipe, that kicks in out-of-band. The user has to prove what they know and what they have to actually connect. So security practice standpoint, strongly, strongly, strongly recommend the use of multi-factor authentication on external gateways. What about internal gateways, though? Do you actually have a need to do this on an internal gateway as well? If you do have keys to the kingdom protected in its own security zone, it could be your Active Directory, it could be your PKI. If you're a technology company, it could be your source code repository. You can force that to be protected by an internal gateway, and you can force two-factor authentication on that gateway as well. So you're now forcing your users to tunnel through to the secure zone, and you're forcing your users to two-factor into that secure zone. So someone wants to RDP to your Active Directory domain controller. This might be something that you want to think about and something that you want to force your users to do. Yes, you're on the inside of the network. Yes, you look like an IT administrator who has this privilege, but we'd like to make sure. So from a security angle, even for internal gateways, in certain dedicated specific conditions, it might be a good idea to force two-factor authentication. Yeah? Trouble with this is adoption. How many of you are using two-factor today? How many are forcing two-factor today? OK, a bunch of hands went down. Why are you guys not forcing two-factor? User experience? Anyone complain about having to key in tokens over and over? Yeah? PANOS 7.1 has a configurable OTP timer, brand new, which can dramatically alter the user experience as it relates to two-factor authentication. So you can now define the time interval with which would actually challenge the user for a two-factor auth. If there are sensitive resources that you're protecting behind a given gateway, and you'd like for a user to two-factor in every single time, you can do that. If you're requiring two-factor for an average user just to give them access to, say, your intranet or perhaps other less sensitive internal resources, and you'd want to have them two-factor, say, once a day, you can do that. So PANOS 7.1 now has configurable OTP timers. We use cryptographically secure tokens in the form of cookies to make this happen. And you can tune the timers based on the gateway to make sure that your security assurance is in place, and at the same time, your users are not complaining about there being too many two-factor authentication prompts and them having to key in 6-digit tokens 8 times a day. Yeah? This was introduced in PANOS 7.0. How many of you are aware of this? There's new radius VSAs that are available with GlobalProtect. And the idea here is to have these VSAs be sent down to the radius server with extra detail, such as, say, the user domain, the client operating system, the client host name, which the radius server can then use to make intelligent decisions. So when the radius server gets a radius access request, it sees these VSAs, and the radius server can go, hey, your client operating system happens to be Windows, and perhaps you trust a Windows PC, and you're OK with a username and password. But if the client operating system happens to be an iPhone, guess what? I'm not OK with just a username and password. I'm going to force you to use a two-factor token. So the radius server can now split off and make selective decisions based on the input criteria, and you can force different authentication schemes for different devices based on these VSAs. Again, strongly urge you to take a look at this. You'll need to import these VSAs onto your radius server. We use these VSAs to make such decisions to make sure that you get to the security posture you need with the client devices. So quickly, from the authentication standpoint, authentication considerations, 3 things come to mind. Strength of authentication. We'd rather have you guys use Kerberos or multi-factor authentication instead of something like LDAP. Ease of use comes in, which is where we'd recommend the use of something like Kerberos, but you know what? There are situations where two-factor, multi-factor authentication actually make a whole lot of sense. And that's the reason the configurable OTP timers exist. So now you can tune user experience even with multi-factor authentication to drive ease of use. And finally, from a security assurance and from an identity assurance standpoint, nothing beats two-factor authentication. We've been talking about this for decades. It's time to go do this, right? It's time to go deploy full two-factor, multi-factor authentication on all sensitive resources and on all external gateways to make sure that you're always asserting the what you know and what you have. And you have full assurance about who that actor happens to be. If the authentication process is complete, this now drives us into user ID. The fact that you're authenticating to the GlobalProtect gateway establishes user ID on the gateway. And you guys have probably seen this slide before, and there's this tiny little part that says GlobalProtect and user authentication. In our mind, this is the most reliable way of deriving user ID. Every single time you have a user coming in, be it internal or external, and you have GlobalProtect in use, you're forcing authentication. If you're forcing authentication, you have reliable user ID. So you don't have to go scrape domain controller logs. You don't have to receive syslog messages from somewhere else. It's just there, and it just works. So to the extent that you can, we'd certainly urge you to use GlobalProtect to drive user ID adoption and to move to user ID enforcement because you get reliable, consistent user ID at all times. Sometime last year, we dropped the portal license fee. There's no fee anymore for the portal license. If you just want to use GlobalProtect in internal mode for user ID purposes, you don't need a gateway subscription. So every single one of you in this room who has a Palo Alto Networks firewall, you can use GP internal mode for user ID with no extra components or no extra licenses or no extra cost. So how think about that? How many of you are enforcing on user ID? I asked this question yesterday and not a whole lot of hands went up. So less than 20% of the room. How many of you are using user ID for visibility? OK, a few more. This can get you to enforcement because you're not worried about the accuracy of data. It's always going to be accurate. Any workstation on your network, GP, internal mode, reliable user ID, start enforcing security policies based on user ID, off you go. Yeah?
How do you use this method in a multi-domain model?
Can we hold questions to the end? We'll get to that. Yeah, I'll help you get answers to that. Yeah? So hammering the point home, 100% reliable, consistent user ID at all times. Use the likes of Kerberos to ease the experience for the user, and the configurable OTP timers to make sure that your users are not complaining about having to key in multiple tokens over and over and over. Yeah? So this is probably the only way, outside of some of the partner integrations we have, to get 100% reliable user ID at all times. Think about it. Give it a shot, given all of you have firewalls, and given there's no more license cost. Set it up in a lab, give it a spin. If you guys like it, would certainly have you deploy that across the board and get cracking. Another quick note, GlobalProtect in internal mode does not interfere with existing VPN components. So if you're using AnyConnect, Pulse, et cetera, et cetera, et cetera, it can live alongside and not interfere with it. So even if you have another VPN solution, you're still OK. You can use this. Yeah? All right, so with that, we'll kick it off to Siva for a deeper dive into how these things actually work. Siva?
All right, thank you, Ashwath. All right, as Ashwath mentioned earlier, a basic knowledge of GlobalProtect is required for you to follow the rest of the session. But since we are all gathered here, I would take a couple of minutes to give you a very high-level overview of what GlobalProtect is and the components that are involved in GlobalProtect. GlobalProtect, as you have here in the past 2 days, extends the security and the protection offered by our next-gen security platform to where the user is. And what that means is, using GlobalProtect, you would now be able to provide the same level of security for the user, irrespective of where the user is. Whether the user is inside your corporate network or outside the network, you can apply the same level of security policies. And GlobalProtect has 3 major components. You got the GlobalProtect app or the agent, GlobalProtect portal, and the GlobalProtect gateways. GlobalProtect app, the function of the GlobalProtect app is to authenticate the users. That's the main function. And as Ashwath was mentioning earlier, if you want a reliable way of getting the user ID, you would want to use GlobalProtect. And GlobalProtect app also establishes VPN tunnel to a gateway if the gateway has been configured and if it requires VPN tunnel to be established from the endpoint. And the other thing that the GlobalProtect app does for you is collecting information about the endpoint. And what does that information include? It can include anything like if you have an antivirus software installed on your machine or not, and if the virus definition file is up to date or not, or it could be information like whether the virus scan was, when was the last time the virus scan was performed. It is a whole lot of information that you can collect from the endpoint using the GlobalProtect agent. And the GlobalProtect agent would report this information back into a GlobalProtect gateway if the GlobalProtect gateway has a gateway subscription. And how to use this information? You would either use it for your security enforcement. You could enforce security policies stating that only if my endpoints have antivirus software installed with virus definitions up to date and the virus scan was performed the last 2 days, I would want to allow access to my corporate resource. You could do that. And if you're not at a point where you wanted to enforce security policies using the host information profile, you could use that information for your visibility. You would know from the reports that the client sent to the gateway how many endpoints have AV installed and how many endpoints do not meet your compliance requirement. You could get all of that visibility if you turn on host information profile and have the agent collect that information for you and report it into the gateway. And portal is a central service to which all the users would go connect, authenticate with. And once they authenticate successfully, that's from where they would download the client configuration. And the client configuration includes information about the gateways that the app can go connect to. It could be an internal gateway or an external gateway. We'll get to that in a minute. And the portal also, as part of the client config, would send information and settings that would control the behavior of the GlobalProtect app on your endpoint. GlobalProtect gateways are your security enforcement points. Once the traffic hits your gateway, that is where the security enforcement happens. And a gateway can be an internal gateway or it can be configured as an external gateway. In an internal gateway scenario, the gateway would be enforcing security policies based on user ID and host information profile for all the users who are inside your network. And as an external gateway, it would function as a VPN termination point where all the users would terminate their VPN on the gateway, and that would be the place where you apply your security policies and enforce security policies for your remote users. With that overview, let's switch gears here and then let's look at what happens internally when the app communicates with all of these different components that we got in GlobalProtect. This is a logical representation of a simple GlobalProtect deployment. This is not a network topology, just a logical representation we have got here. As you could see, we have remote users, and then we got a portal, and you got your external gateways. 2 external gateways are shown here. And within your corporate network, you got your users on the LAN side, and you got your servers on the data center. And these two are segmented by an internal gateway inside your network. Now, the first connection that the user on your endpoint would do is connecting to the portal. Now, let's look at focus more on what the app would do when it talks to the portal. When the user initiates the connection, the app goes and talks to the portal first, and what we call it as a pre-login. During pre-login, the app does an SSL handshake with the portal and verifies the server certificate of the portal. That helps the app to validate if the app is talking to the right portal or not. And after pre-login, we get into the authentication phase. And this is when the user gets authenticated to the portal. And the authentication method and the credentials to use for authentication all depends on the configuration that you got on the portal. It depends on the authentication profile and the certificate profile that you have configured on the portal. If the user successfully authenticates with the portal would then push down something called a client config to the endpoint. The clients would get this configuration after a successful authentication. And what does a client config include? It includes a list of all the gateways. It includes gateways that are internal. It includes gateways that can be external. And it also includes something called an internal host detection parameter. And that's the parameter that the endpoint would use to identify whether the client or the endpoint is an internal network or in an external network. And a portal can also be used to distribute client certificate. How many of you here are using certificate-based authentication to the portal or the gateway? And how many of you agree with me that distribution of a client certificate is a difficult thing to do? A lot of you. With PanOS 7.1, we have a feature, we have enabled portal to act as a SCEP client. And what does that mean? Since portal can act as a SCEP client, it can go request a certificate on behalf of the user when the user authenticates with the portal. And what that means is a portal would now be able to distribute a unique client certificate to all of your endpoints. So if you're looking for a way to distribute client certificates to endpoints, a unique client certificate to endpoints, you could look at a PanOS 7.1 feature, which is enabling portal to act as a SCEP client. And we also got HIP check parameters. HIP, it is host information profile. As I said, that's the endpoint profiling. And the portal sends this information stating to the agent whether it has to collect the HIP information or not. And if it has to collect information about certain categories and exclude certain categories. And finally, you got the agent configuration, which says how does the agent behave? How does the agent connect to the portal or the gateway? What is the connect method to use? Quick raise of hands, how many of you enable GlobalProtect in an always-on mode? Few hands. You might have heard us say this before. If you wanted to secure the internet traffic for your mobile workforce, you would want to be enabling GlobalProtect in an always-on mode. And besides that, you would also be disabling split tunneling. That's the only way you can have the traffic come back to the firewall, and that's the only way the firewall can inspect all the traffic all the time, irrespective of whether the user is inside your network or outside your network. So please do enable always-on and disable split tunneling. And so that's the primary purpose of the portal, to get the client config distributed to your endpoints. And how often does the client go and talk back to the portal? Client would talk to the portal every time the user authenticates with the portal. And if you have enabled always-on mode, the client would then be contacting the portal every 24 hours. That's the portal config refresh interval by default. And every 24 hours, the client will authenticate with the portal to download the client configuration. And in an always-on mode, since the client is always connected to a gateway, the client would be contacting at every 24 hours as configured here by default, but it is configurable to anywhere between 24 to 168 hours. That's the entire communication that happens between an agent and the portal. Now let's look at the scenario where the user has moved inside an internal network. So the user is in an internal network, and let's focus our attention at what happens between a GlobalProtect agent on an endpoint which is in an internal network and the internal gateway. The app begins by doing a network discovery. So the app has already got the client config from the portal, and then the app would now begin to do something called a network discovery. Network discovery allows the app to identify whether the endpoint is an internal network or an outside network. And to do that, it would make use of the internal host detection parameter that it had obtained from the portal config. We do a reverse DNS lookup to see if we can resolve the internal host. And if you are able to successfully resolve the host, that means the client is inside the network, and you are able to reach the internal host. And in this case, the client is identified as internal network, is in the internal network. And after this, the client would start to authenticate with each of the internal gateways that are configured in its portal config. So if you got 2 internal gateways configured for this agent, the client would start to authenticate with each internal gateway one after the other. This helps the internal gateways to get the user ID reliably. So the internal gateways that were successfully able to authenticate the users now have the user ID from this endpoint. And after the authentication is done, the GlobalProtect app would send something called a hip check message to those gateways that it was successfully able to authenticate with. The hip check message includes the MD5 checksum of the hip report that it has most recently collected. And once the gateway receives the hip check message, it will try to compare the hip check message with what it has already got from the previous hip report that was submitted by the same endpoint. And if there is a difference between the hip check messages, that's when the gateway would request the client to send the hip report. On receiving this request, the GlobalProtect agent will send the hip report to each of the internal gateways to which the agent was able to successfully authenticate with. At the end of this process, each of the internal gateways will now have the user ID because the user had authenticated with the GlobalProtect, and because the agent has also submitted the host information profile, the gateways also have the host information report with them, which it can use for security and policy enforcement. So user ID and the device profiling are all available on all of the internal gateways that the user is able to authenticate with. That's the internal gateway communication from the GlobalProtect app. Now let's look at a scenario where the user has moved remote, is working from hotel, or is not inside a corporate network anymore. In this case, let's focus on what's happening between the GlobalProtect app and the external gateways. As usual, after receiving the client config, the GlobalProtect app will start to do a network discovery. And in this case, because it is not able to resolve the internal host successfully, the client identifies itself to be in an external network. And because they are identified as to be in an external network, the GlobalProtect app will begin something called an auto discovery. So you can list multiple gateways as external gateways. And why would you want to deploy multiple external gateways? In case if you have your user population distributed across all over the globe, and if you wanted to make sure that there is not a lot of latency issues for your end users, you would deploy gateways as close as possible to where the user is. And so if I'm a user in California, I would want to be connected to a gateway which is closer to me. A gateway in California would help me for that. And having configured and deployed multiple external gateways, and you would turn on auto discovery on the portal. And the client would start to do the auto discovery immediately after it identifies the client is in an external network. During auto discovery, the client would begin an SSL handshake with each of the external gateways that participate in auto discovery. And based on the SSL response time and the priorities that you configure for each of the external gateways, the client would identify what is the best gateway that it can connect to. In this scenario, let's assume external gateway 2 is the best gateway. This is when the client would start to authenticate with the external gateway 2. After successfully authenticating with this gateway, again, authentication method and authentication credentials all depend on what you have configured on that external gateway for authentication. After you authenticate successfully, the client would establish a VPN tunnel with that external gateway. And after the tunnel setup, the client would then send a HIP check message which contains the MD5 checksum of the latest HIP report. Gateway compares to see if the HIP report has changed by comparing the MD5 checksum. If there is a change, the GlobalProtect gateway, external gateway 2, will request the client to send the most recent HIP report. And the client would send the HIP report back to external gateway 2. So at the end of this process, you got external gateway 2, which has successfully authenticated the user. It has the user ID, and it has also got the HIP report from the endpoint. The difference between an internal gateway scenario and an external gateway scenario is that in an internal gateway scenario, the client authenticates with all of the internal gateways, and in an external gateway scenario, the client authenticates and sets up a tunnel with a gateway that's identified as the best gateway. Now let's look at the scenario, what happens where you have configured the host information profile to be reported by the GlobalProtect client. Any of you here who's using host information profile? A few hands. Good. So the host information profile that is collected by the client and reported back to the gateway is not used for deciding whether the user can connect to the gateway or not. It is not a connection determining thing. The HIP report is being used only in the security policies, meaning the HIP report would be used to decide whether the user can access a particular resource or not. It will not determine whether the user can get connected and establish a VPN tunnel. It will only be used to decide whether a user can access a resource or not. Now let's look at what happens in a HIP workflow. If you have enabled HIP data collection on a portal config, the agent, as soon as it downloads the client config and the user has initiated the connection, the agent would start doing the HIP check on the machine. The reason we start this as soon as possible is because, as you know, collecting the information up from the endpoint for all of these different checks like antivirus check or checking for if this anti-spyware software is installed or not could be time consuming. And we are, by doing this, by starting the HIP check right away, we are giving a chance to the endpoint or the GlobalProtect agent to collect as much data as possible as soon as the authentication is complete so that it can send back the report. And when the HIP check is happening at the endpoint, the GlobalProtect agent also starts network discovery in parallel. This will allow the agent to identify whether it is inside the corporate network or outside of the corporate network. And depending on where the user is or where the endpoint is, the client would then would authenticate with the gateway, and then it would establish tunnel if it is in an external gateway scenario. Right after this is the time when the GlobalProtect agent will have to send the HIP report back to these gateways. And in case if the HIP check, which as I said could be time consuming, especially if you have enabled HIP check for checking the machine for missing patches on your endpoint, it could take a lot of time. And in case if the HIP check has not completed by time, and we also have something called a max wait time until which the GlobalProtect agent would wait for the HIP check to be completed. If that has not completed by the time, instead of waiting for the HIP check to complete, the GlobalProtect agent would send whatever it has collected so far as a HIP report to the gateway. Why do we do that? That's because we wanted the gateway to have as much information as possible about the endpoint so that it can be used for security policy enforcement. We don't want to wait forever to have all the information from the endpoint. We'll collect as much as possible as soon as possible. And in the meantime, the HIP check would have completed at the endpoint. And what does the agent do after the HIP check completes? It caches it locally so that it can be used for future purpose. And HIP check always happens at every 1 hour, meaning if I had done my HIP check at 10 o'clock, the next HIP check would happen at the endpoint at 11 o'clock. As I said earlier, hip check is something which could be a time-consuming process. So what we do, what GlobalProtect agent does intelligently is, based on how much time it took last time, and since we know that it is always going to take longer, minutes before the hip check interval kicks in, the GlobalProtect agent would start to do the hip check. This would give enough time for the GlobalProtect agent to collect all the information about the endpoint. And again, then when the hip check begins and the hip check is not able to complete, it would use whatever it has collected so far. And remember, we had also cached the report from the previous hip check. For all of those categories for which the hip check was not able to complete, it would use the cached result and put on a report that is sent back to the gateway. So at this point, the GlobalProtect gateway will have a RIP report which has the results of all the most recent hip check that was done. And it also includes, for those categories for which the hip check was not able to be completed on time, it would include the result from the previous run. That way, the gateway has all the information that it can use for security policy enforcement. This is what happens at the endpoint during a hip workflow. So, as we said, hip is something that you would want to use for two purposes. One, if you want to have visibility of all the endpoints on what they have as an antivirus software that's installed or not, and if you want to see whether the endpoints are compliant or not, you would use the hip check for visibility purposes. And beyond that is when you would start enforcing your security policy, stating that only if the device is compliant, you would allow access to your sensitive resource. So there are two purposes for hip check. With this understanding, I would then turn it over to Andy, who would walk you over through some of the use cases based on the information that you got so far.
So I'm going to address a use case that I get a request for about Mike what? Is it on now? Oh, wonderful. Actually, I'd rather turn it off and just yell. Anyway, I'm going to address a use case that I get a request for usually about 3 to 4 times a month. And this use case is really around an idea where you need to step up your authentication for resources that are sitting behind or in a zone that are much more sensitive resources, right? The things that you really, really, really want to protect. So the idea here is, and for those of you that have GlobalProtect implemented, the idea here is the ability to allow your user to select manually a particular gateway, and then once they've selected that gateway, having something like a two-factor authentication, some multi-factor at least of authenticating to that gateway in order to get to that resource. I don't have a lot of time. We definitely want to take questions, and this is not a tutorial to show you exactly how to do it. However, it's good reference material. Thank you. It's good reference material for when you do need to implement this type of an architecture, okay? So hopefully I'll be able to get forward on this. Here's the environment that I've set up. I'm using PanOS 7.1, right? It was just released yesterday. I'm using GlobalProtect Client 3.0, released probably a month ago. Active Directory Windows server, on a Windows Server 2012. I'm going to configure, or I'm going to show you 2 different gateways. Gateway 2 is an auto-selected gateway. In other words, I'm using single sign-on here. When the user authenticates to their Windows machine, it will automatically authenticate them to gateway number 2. Okay? Gateway number 1 will be manually selectable, and gateway number 1 will have two-factor authentication associated with that gateway. In order to do this, I needed to use a one-time password facility, and I did that through a Radius server. I'm using actually OpenOTP. It's a kind of a free OTP type thing, but it is Radius based. And of course, Google Authenticator has been integrated with this so that I can get that 6-digit code to type in. Now the steps that I'm going to take in order to make this happen is I'm going to create a loopback interface. Now you're not going to do that. You'll probably create a interface that is a physical interface with a publicly addressed entity to it, right? You'll be able to connect to it from the internet. I'm using a loopback interface just because I can. I'm going to create a tunnel interface. I'm going to create a certificate and then also a certificate profile so that I can identify whether I'm going to use TLS 1.0 or I'm going to use 1.5, whatever. I'm going to create my two-factor authentication profile, which is my radius profile. I am then also going to modify my portal to add the client, that gateway, into the list of gateways that my users can select from. Then I'm going to create the gateway itself. And I'll show you a demonstration of how that really looks to your end user. So let's go through this very quickly. In this case, I created a loopback interface and I gave it interface 3, right? What I did then was I gave it an IP address. Why did I do that? Because I want to test. I want to make sure I can get to that IP address. And then finally, I'm going to give it a management profile so that I can at least turn on ping. Then what I did, and this is what it's going to look like in my list. Then what I did was I created a tunnel interface. When I created this tunnel interface, I put it into a zone called GlobalProtect. Why did I do that? I did it because I want to be very granular with my security policies. I want to make sure that I can write a policy that gives me access from GlobalProtect to other zones where the resources reside. I gave it an IP address and I allowed it to be pinged so I can test, right? Now I may turn that off later on. And that's what that would look like in my tunnel interface tab. Now what I did was I created a certificate. I already had a root certificate on this device, so I basically created a server certificate. Keep in mind, if you're using fully qualified domain names, continue to use fully qualified domain names, but make sure your DNS can resolve it. I get that question all the time. How come I'm not connecting? Well, did you put it in DNS? No. Do it. If you're using IP addresses, you can do the same here, underneath the common name. Right? So I created my certificate, and then I have to create my SSL TLS service profile, which basically allows me to set a minimum and maximum for my TLS range, right? And that's what that looks like. So we've created, so far, all of the pieces, right? Now what we're going to do is we're going to define how we're going to authenticate, right? In this case, I'm going to authenticate two-factor authentication on the gateway. So I want to make sure that I've created a radius authentication server and then a profile. In this case, the server. And then I create my profile, which then allows me to now add a gateway to the portal. Okay, in this case, I added gateway 1 to this portal's agent configuration. So when the user authenticates to the portal, the list of gateways gets pushed out to the agent. Now I'm going to create the gateway. In this case, I'm giving it its name. I'm telling it what interface and the IP address of that particular gateway. And under authentication, I identify radius. This is my two-factor authentication for this particular gateway. Okay. And of course, I have to give it, because I'm tunneling here, I have to give it a range of IP addresses that will be assigned for the use inside the tunnel. Now, with all of that done, you should be able to see this experience. Now keep in mind this is a single sign-on scenario, so when I authenticate to the device, it's going to use those credentials to authenticate to the portal as well as and bring up a connection to the gateway. Oh, come on. Seriously? There we go. User signs in. What's going to happen is it's going to automatically select that one gateway, gateway number 2. It's going to authenticate the user using single sign-on, and you should see down in the lower right-hand corner where the service comes up. This means I have a VPN session to gateway number 2 in this case because it's an auto-selected. Now what I'm going to do is I'm going to have the user go into the client, and he's going to drop down the client and select gateway number 1, which is viewed for him. Notice it automatically comes up and says, what's your one-time password? Now, in the background, I opened up Google Authenticator, and I had a 6-digit code on my phone. I just simply typed that in, and now I'm connected to the other gateway, which is protecting different resources, resources that are very sensitive resources, if you will. So what I'm trying to show you here is the fact that you can automatically select certain gateways, and that's where a lot of our customers do, what a lot of our customers do. However, you do also have the ability to mix in those manually selectable gateways along with it for those special situations. Now we're going to open it up for questions, and we don't have a lot of time, but Siva? Ashwath?
Hello. Okay, so my question is for all the new GlobalProtect features that you can configure in 7.1, do you have to be at the 3.0 client?
No. You can run an older client with the 7.1 code.
Okay, so all the new configuration settings.
The nice thing about 3.0 though is that a lot of things were changed in how it looks and how you work with it, right? We made things a little bit more intuitive in terms of where you find information. In the older releases, you had to go to a couple of different tabs inside the agent in order to find some things that you were looking for, like status, IP address, things of that sort. Today, you click one button that says status, and it shows you the IP address. It shows you what tunnel type you've got, whether it's SSL or IPsec, and all of it is in one place. It's much more intuitive.
Is there a reason why you can't use a portion of the HIP check to stop users from authenticating via a home or a non-corporate device? Why not build that into the HIP check and incorporate a portion of the HIP check so that you can say it must have domain authenticate,
Yeah, so when you configure HIP, you would start off by configuring HIP objects, and you could have multiple HIP objects. An object could be something that checks for only an antivirus software, and you might have one more HIP object that checks only for your, for example, if there is a missing patch on your endpoint or not. So as long as you create multiple of these HIP objects for each of these categories, you can pick and choose what you want in your HIP profile and use that for security policy enforcement. Is that what you were asking for? Okay, so I understand your question now. So you're asking why do we not use the HIP information to determine whether the user can connect to the gateway or not? Okay, so for us what we wanted to do is we wanted to see all the traffic, and that's the reason why we want to allow the user to get connected to the gateway. Only when the user gets connected to the gateway, the traffic comes to our firewall. So we want to see that, And what we do in the security policies is we'll make sure that any resource that he can access, only if it is a compliant device, we would enforce that using the HIP profile. So we want the user to get connected in order to see the traffic. That's the reason why we do not make a decision whether the user can connect or not based on HIP.
We have maybe time for one more right here.
Yeah, in our environment, we have a lot of users who have admin rights to their clients. If you uninstall GlobalProtect, is there a way the portal or gateway can enforce it back to use GlobalProtect?
If the users have admin rights, yeah, they can uninstall GlobalProtect. And to enforce GlobalProtect, if you have security policies that says only if the users are connected and coming through the VPN tunnel, or only if they are coming through with a valid user ID, then it would force them to actually get their GlobalProtect client installed and then get connected. There is not a way to push down the GlobalProtect client automatically if it is not there. But using security policies, you should be able to have the user go do it right away.
All right. Thanks, folks.
Okay, thank you.
Appreciate it.